Hey everyone, welcome back to AP Calculus AB and BC course. And in this session, we are going to start Unit 8, which is Applications of Integration, which weighs around 10 to 15% for the AB students and 6 to 9% for the BC students. Okay, so these are the subtopics in this chapter, applications of integrations. We will start with finding the average value of the function and then we will discuss few problems, how we relate position, velocity and acceleration using the integrals and differentiation also. Okay, we have other topics like finding the area under the curve, finding the area made by a curve with x-axis or y-axis or between two curves, then volumes of solids of revolution, like if you have something and you revolve it around one axis through 60-degree angle, right? What shape you get? These type of things are there. So, in order to have a one-on-one session or group session, or you need any help, you can contact us for your and you can book your free demo also using this WhatsApp number or Telegram. Okay. So let's start with applications of integration part 1, which is finding the average value of a function on an interval. So for finding the average value, what that means? It means that if a curve is given to us, okay, if a curve, let's say this is our system and this is the equation y is equal to f of x. In order to find the average value of this function, starting from this, let's say x equals to a up to this x equals to b. Okay, we are looking for average value of this function within this interval. How to find that? Average is given by what? Sum of all observation divided by total number of observation for discrete values. But for these continuous values, what we do is we take integration of the y values, which is given by integration a to b f of x dx. That's your numerator part. And for denominator, what is that? We need this a sum of x values. So again it is continuous, so we will take b minus a. So that's it. It's your formula. Okay. So this is the formula for finding the average value of a function in an interval a to b, which is integration a to b fx dx divided by difference of the limits b minus a. Okay. So let's solve a question on this. We have to find the average value of the function gx is equal to square root of x plus x over the interval 4 to 9. So here what we have, a is equals to 4, b is equals to 9. Okay, so b minus a is simply 5. And now what is our function? Our function g of x is given as root x plus x. We already know how to integrate it. It's simple, right? Algebraic function. So I will use the formula for finding the average value of a function given by this. Now just plug in gx as root x plus x and b and a values in this. So in the next step, I will get integration from 4 to 9 of x raised to the power 1 by 2 plus x dx whole divided by 5. Now for x raised to the power 1 by 2, simply its integral is what? Increase one power, so half plus 1 divided by the same power, which is that half plus 1, 3 by 2 basically. Plus the integration of x is simply x squared by 2. Then you add plus c, constant of integration. But since it is definite integral, we don't need to add constant of integration in this one. Okay. So yes, in this case, you can remove this. Okay. Now use the upper limit minus lower limit part. Okay. Once you do this, put 9 everywhere in place of x, then put a negative sign, then put 4 everywhere in place of x. Get your answer. If GDC is allowed, it makes it simpler, much simpler. So after solving it, you will get 271 divided by 230 as your value. Okay. So in this way, you can find the average value of a function. Now the next part is how these rate of changes are related to each other. Let's discuss everything with the help of this question. You know that if we have the displacement function, let's call S as the displacement function, okay? Then its derivative ds over dt. What is that? It is the velocity v, right? And if we take one more derivative of the displacement function, that gives me derivative of velocity one time with respect to t, or we call it acceleration. These are the relations, right? And in order to get the displacement from the velocity, if the velocity function is given to us, for example, in this case, it says a particle velocity over the time in inches per second is given by this Vt is equal to 3t squared minus 10t plus 15. That is the velocity function. So this time velocity function is given to us. They said find the if the particle's position at t equals to 1 seconds is 8 inches. What that means? It means if t is equals to 1, then displacement function s will take value 8. Then find the exact position of the equation of particle st. So this time velocity is given. We are looking for s. So how can I find s function? It is nothing but the integral of the velocity function simply. Okay, so first part. Now let's start with the A. It here you just need to integrate that. S of t is the position of the particle at any point, basically, right? Displacement at any point. So which is nothing but the integral of this 3t squared minus 10t plus 15. Okay, dt. Now if I integrate it, I will get the position of the particle at any point, which comes out as 3t squared cubed by 3 minus 10t squared by 2 plus 15t plus c, where c is constant of integration. How to find c value? It's obvious, right? Here it says s equals to 8 when t equal to 1. So I will use that point using initial value problem, or this 1 comma 8 point in this. So we get 8 s value is equals to, this is what, t cube only. So t cube means 1 cube minus this is 5. Okay. So minus 5 times 1 squared plus 15 times 1 plus c. So from here we got the value of constant of integration c. Simplify it and get the answer. So what it gives me? It gives me 16 minus 5 gives 11 and minus 3. C comes out as negative 3. So therefore, the displacement function s of t, right, at any point t is given by t cubed minus 5t squared plus 15t minus 3. This is the answer for the first one, because they said find the exact position at any time t. Okay. Now in the B part, it says what is the distance traveled by the particle from t equal to 0 to t equal to 5. Distance, there is a difference between distance and displacement. Actually, in order to find the distance, this was the displacement. In order to find the distance, let me tell you, you need to integrate v modulus. Okay, that's it. Modulus v dt gives you the distance traveled by the particle in that time. The thing is, see, if a particle is moving along x direction like this, it goes up to this point for starting from t equal to 0 to, let's call it, t equals to t1, and it goes back up to this distance, that takes time t2, and goes again forward here, reaches here. So the displacement of this particle is given by this distance x3, let's call it x3 only. X3 is what? Displacement traveled by particle in its journey from 0 to t3 time. But if I say find the distance, so what is distance? Distance will be given by the distance traveled first, which is x1. Okay, so take this x1, then plus the distance traveled during this interval from t1 to t2. Let's call it x2. So I'll take modulus if you want to take modulus x2 plus then the distance traveled from here to that third point as well. You can take this one. Starting from this again, let's call it x3. So x3. I'm taking modulus because distance I'm keeping as positive. It is always a non-negative number actually. So this will be my final answer. This is the total distance traveled by the particle. In case of displacement, it is simply x3 only. But for distance, it is mod x1 plus mod x2 plus mod x3. Okay. Now B part. It says, what is the distance traveled by the particle from 0 to 5 seconds? So here, in order to find the distance, you can use your GDC if it is allowed. For this problem, it says 0 to 5. Take modulus of that function. What is the velocity function? 3t squared minus 10t plus 15 modulus dt. If you take modulus, that's fine. It gives you direct distance. If you don't take modulus, then you have to break it into parts. Find those intervals in which the velocity function is increasing or going backward, right? So when you simplify it, it gives you 75 inches as the answer. Okay. Next one. Next is C. It says at what times from t equal to 0 to t equals to 5 seconds is the particle traveling in its average velocity? For finding that time where the velocity is average velocity, first we need to find what is the average velocities, right? So let's first find average velocity. Average velocity is what? Take using the previous formula, average value. So I can say 1 over, what is the total time? 1 over 5 minus 0, then integral from 0 to 5 of function, what is that? 3, this one, 3t squared minus 10t plus 15. Okay, whole divided by this, 5 minus 0 already done, dt. Okay, so when we simplify it, we will get, it was 75, we already calculated that. 75 by 5 gives me 15. So 15 inches per second is the average velocity of the particle. So now what this says in the question, it says find the time at which the velocity becomes equals to average velocity. So velocity formula is already known to us. What is that? 3t squared minus 10t plus 15. This should be equals to 15. Now we have to solve for t. It's a quadratic equation. If you want, you can use your GDC. Okay, that gives you faster answer, or you can simplify it directly. 15 to 15 cancelled. You got t common. So 3t minus 10 equals 0. And hence there are two timings at which the velocity will be equal to average velocity. One is t equals to 0 and other is 10 by 3. 10 by 3 seconds. These are the two timings. Okay, so in this way you can calculate the displacement, velocity, and if this says acceleration also, you can also find acceleration. If velocity is given, then finding the displacement in this way. Okay, please note down this. So now next part is length of rectangular curve or arc length. Basically, we can use the formula which is integration a to b square root of 1 plus fx squared dx for finding the arc length. I'll show you how we got this. Consider that we have a function, okay? This is function and we are looking for its arc length starting from this point to this point. Let's call this as x equals to a up to this x equals to b. And the equation of the curve is, let's say, y is equals to f of x. Now we need to find the arc length. Okay, we also call it quadrature. So in order to find this arc length, let's call it AB. Okay, so the arc length AB is given by this formula, but how we got this? Hmm? So in order to do that, let's consider a very small portion of this, very small, right? So like this. So if it is very small, it will become a straight line almost. Okay. Now, in order to reach that, what distance you traveled along x and what distance you traveled along y? So what is that? That is delta y for the y distance and delta x for distance horizontal. Right? This one. So I'll, if the distance is very small, then we use dy and dx. Okay, delta x is only change, but when delta x approaches to 0, right, then we write it dx. Dx is 0, limit approaches to 0. limit this. Now, what is that? On this curve, if I take a very small piece of it, horizontal distance dx, vertical distance dy, what is the hypotenuse? I can use Pythagoras theorem. So using the Pythagoras theorem, I can say this, let's say this one is smaller distance, okay? Let's call it delta L. Delta L is equals to this dx squared plus dy squared, okay, inside the square root. Now dx out. So delta L by delta x is equals to square root of 1 plus dy by dx whole square. Now if you integrate it, okay, you can take this dx outside also here. Now if you integrate it from the curve, on the curve from A to B, okay, that gives you L, arc length, and hence the arc length comes out as A to B integration of square root of 1 plus dy by dx squared dx. Answer. So in this way we got the arc length formula. Simple. We just took a small part of it, calculated the hypotenuse, and then integrated it throughout the curve. Okay, so let's solve a question on this. It says find the length of the curve y is equal to sine x from 0 to 3 pi by 2. So here what is that? We have y value as our function. So f of x is sine x, and we can find its derivative. What is that? F dash x. What is f dash x? Derivative is cosine x. So we need to take square in order to plug in these values in this. Also we have a lower limit as 0, upper limit b as 3 pi by 2. Now plug in these values in this formula. We got integration from 0 to 3 pi by 2 of square root of 1 plus cosine squared x. Okay. Now either use your GDC to get this answer, right? You can simply use your GDC to get this answer, which comes out as 5.730. So this is the length, arc length you can say. If you look at the curve of sine x graph, so from 0 to 3 pi by 2, this. This arc length comes out as 5.730. Okay. So that is it for this part, and we will continue with the next topic in the next session. So today we started with the average velocity of the function and found that it is given by 1 over b minus a, difference in the x values, and they have to integrate it from a to b f of x dx. That is the average value of the function. And then we saw how these position, velocity, acceleration, distance are related to each other with respect to integral and differentials. Okay. So after that we calculated the arc length of a smooth planar curve. Okay. So that's it for this. Thank you for watching this. And if you need any other help, please feel free to connect with us on this number. Keep watching, keep learning. Thank you.